So a couple of things that we've learned from before. We have an inflection point when it changes concavity. So if we can show that it doesn't change concavity, then that would show that it is not an inflection point. It might also be able to show that it's not an inflection point if we also show that it's a minimum or a maximum. So at this, if we take our first derivative, we're going to get 4x cubed, which is only equal to 0 when x is equal to 0. And checking the first derivative test, we're going to find out that it's negative before 0, positive after 0. So at this point, we know that at 0, 0, we have a local min. When we do our second derivative, we get 12x squared. If we make that equal to 0, again, x is equal to 0. So it made us think of a possibility of an inflection point. Now, when we actually go to check before 0 and after 0 into our second derivative, they're both positive. So they're both concave up. Okay, now how do we write this out? How do we use what we've shown here to make a statement so that we can convince someone that we know that there's not an inflection point? Okay, so f of x does not have an inflection point, since the only value where the second derivative is equal to 0 is at x equals 0. But f of x is concave up before x equals 0 and concave up after x equals 0. So it does not change concavity, and therefore there are no inflection points. So that's one possible way of saying that we would know for sure there's no inflection points, because an inflection point is where it changes concavity. So just use the derivative. I show that it's concave up before, concave up after, so it can't be an inflection point. The other thing you could do is you could say that since f prime of x is equal to 0 at that point as well, and we know that it's a local minimum, it also can't be an inflection point, because you can't have a change of concavity at a minimum or at a maximum. But I like the showing the concavity the same on both sides. I find that's an easier way of explaining that it's not an inflection point. So there's some questions there that you can do for practice. We're going to take the rest of class to work on those.